I, Sasibhushan Tiwari, welcome you all to this channel. JEE Advanced 2023 के फिजिक्स पेपर 2 में वेव ऑप्टिक्स का ये क्वेश्चन थोड़ा डाउटफुल लगता है. We will just look at this question from the point of view of a physics student. Nothing is wrong or right. We all are here to learn only. So let us have a deep look into this question. Looks like it could have been presented in a better way. A monochromatic light wave is incident normally on a glass slab of thickness D. This is a glass slab of thickness D, as shown in the figure. The refractive index of the slab increases linearly from N1 to N2 over a height h. ग्लास का रिफ्रैक्टिव इंडेक्स यहाँ N1 और ऊपर चलता हुआ लीनियरली बढ़ता हुआ N2 हो गया. Which of the following statements are true about the light wave emerging out of the slab? जो लाइट वेव बाहर निकलेगी स्लैब के, it will get deflected up by this angle, it will get deflected up by this angle, it will not deflect. The deflection angle depends only on N2 minus N1 and not on individual values of N1 and N2. Please read this question if you haven't read before. This is the glass slab. यहाँ refractive index N1 है और यहाँ पे N2 है. Refractive index N1 से N2 linearly बढ़ रहा है. Okay, fine. Linearly बढ़ रहा है का meaning ये हुआ कि अगर आप यहाँ से y हाइट पे हैं, इसको y0 मान लीजिए और यहाँ से y हाइट पे हैं, तो यहाँ पे जो रिफ्रैक्टिव इंडेक्स होगा एट हाइट y, इट विल बी n1 प्लस n2 माइनस n1 बाई h इंटू y. द रिफ्रैक्टिव इंडेक्स इज ग्रोइंग linearly. This is what it means. Now, this is light ray, and these are wave fronts, obviously. So a wave is incident, both wave fronts as well as light rays. They are constructions only to represent the propagation of light, nothing else. After this light wave crosses this slab, by what angle it has deflected? That is the main question. And most of the solutions that are available show a diagram like this, and this is how the solution is given. I said most of, because I don't have access to each and every solution that exists in this world. But whichever solution I have seen, it is more or less like this only. And this does not seem to be very appropriate. The solution is based on this fact that PQ is one wavefront of the emerging light, right? And if PQ is a wavefront, then this optical path length should be equal to this optical path length. Optical path length here is N1 refractive index into D plus this length L. So L plus N1D is optical path length from here to here. And optical path length here is N2 into D. N2 is the refractive index there. So both should be equal. So from here you get this value of L as N2D minus N1D. And looking into this diagram, tan theta is L by H. So L is N2D minus N1D by H. So question is solved. This is the deflection angle. If you don't understand optical path length, you can think in terms of time. It is basically the same thing. The amount of time that light takes to travel from this point to this point, in that time interval, light here will go from this point to this point. Because यहाँ refractive index कम है, यहाँ speed ज़्यादा है light की. So it will cross this glass slab at this point earlier as compared to this point. So थोड़ी देर तक ये light हवा में भी चला गया. So thinking in terms of time also you can arrive at this equation. I am not doing that. But there is a flaw in this diagram as well. The answer is right, wrong, I am not commenting on that. But there is a flaw, conceptual flaw in this diagram, and I wish to highlight that. But before that, first of all, let us investigate the statement of the question itself. The question says nothing about D. It says nothing about magnitude of N1 and N2. Is N2 too large compared to N1? Possibly, because nothing has been said. Is D significantly large? Possibly, because nothing has been said. If D is significant, then it is a mistake to assume that light ray will travel straight inside the glass slab. It is a medium having variable refractive index. And if you know Huygens wave theory आपके syllabus में और उसी पे based ये question है. So if you know Huygens wave theory, then you must understand that light ray will not be on this path or on this path or on this path after it enters into the glass. Impossible. This is one wavefront that is hitting the glass surface. Okay. Very small time after this, let us draw the new wavefront. In fact, when the medium is variable, to use Huygens wave theory, you should be drawing wavefronts at infinitesimally small intervals of time. Otherwise, it will make no sense. ठीक है, अभी ड्राइंग में जैसा भी दिखे, यू अज्यूम कि बहुत छोटा टाइम है. जस्ट एक इंट्यूटिव आइडिया के लिए बना रहा हूँ. आई एम नॉट ट्राइंग टू बी एग्जैक्ट, विच इज अ बिट डिफिकल्ट हियर. जैसे ये वेव फ्रंट यहाँ हिट करता है एक बहुत ही छोटे टाइम इंटरवल के बाद, यहाँ पे इसको अगर पॉइंट सोर्स माने तो वेव फ्रंट कुछ ऐसा दिख रहा है. लाइट की स्पीड यहाँ कम है. इट विल नॉट बी एग्जैक्टली स्फेरिकल, आई नो दैट, क्योंकि इस डायरेक्शन में ऊपर चलने से वो बदल गया रिफ्रैक्टिव इंडेक्स. दैट्स व्हाई आई एम सेइंग वी हैव टू अज्यूम इनफाइनाइटेसिमली स्मॉल टाइम इंटरवल. ओके, अज्यूम इनफाइनाइटेसिमली स्मॉल टाइम इंटरवल. लाइट बहुत दूर नहीं गया है, बट अब मुझे ड्राइंग में तो ऐसा दिखाना पड़ेगा. उतने ही छोटे से टाइम में यहाँ पे थोड़ा बड़ा स्फीयर बनेगा. ये पॉइंट सोर्स है, इसको सेंटर मान के एक वेव फ्रंट बना रहे हैं हम, वेवलेट्स. और यहाँ पे ज़्यादा बड़ा स्फीयर बनेगा. इन सभी का कॉमन टेंजेंट नया वेव फ्रंट होता है. तो वेव फ्रंट तो बेंड हो गया. वेव फ्रंट के परपेंडिकुलर रेज होती हैं, तो रेज तो बेंड हो गई. तो ग्लास के अंदर तो लाइट बेंड हो गई ऑब्वियसली. तो हम ये पाथ ऐसे दिखाना तो गलत हो गया, एकदम गलत हो गया. बट ओके, क्वेश्चन भी फिर बहुत कॉम्प्लिकेटेड हो गया. अगर क्वेश्चन में ये स्टेटमेंट दिया होता कि D इज स्मॉल, जो कि नहीं दिया हुआ है, होना चाहिए था, तो D स्मॉल होने से हम शायद ये अज्यूम कर लेते कि जो लाइट का लैटरल मूवमेंट है वो नेग्लिजिबल है. इसका मीनिंग ये हुआ, हम ये अज्यूम कर लेते कि एक लाइट रे ग्लास स्लैब के अंदर ऑलमोस्ट स्ट्रेट रह गई. एक्चुअल में इसका लैटरल मूवमेंट होगा. इसको आप ऐसे इंट्यूटिवली देख लो कि इस ग्लास स्लैब को अगर मैंने मल्टीपल लेयर्स में डिवाइड कर दिया, वेरिएबल रिफ्रैक्टिव इंडेक्स, बहुत थिन लेयर है, रिफ्रैक्टिव इंडेक्स धीरे धीरे बड़ा होता जा रहा है, ऐसा मान लो एक मिनट के लिए. ये लाइट रे ऑलमोस्ट ग्रेजिंग इंसिडेंस पे आई, नॉर्मल इंसिडेंस पे आई, आई एम सॉरी, ऑलमोस्ट नॉर्मल इंसिडेंस पे आई, नहीं ग्रेजिंग इंसिडेंस. ओहो, दीज आर, आई एम सो सॉरी, दीज आर दी लेयर्स. ऑलमोस्ट ग्रेजिंग इंसिडेंस पे आई, ऑलमोस्ट 0 डिग्री पे आई. बट यहाँ से यहाँ का रिफ्रैक्टिव इंडेक्स जाता है, इट विल बेंड टुवर्ड्स नॉर्मल. ये थोड़ा ज़्यादा दिखा दिया, बट ठीक है. यहाँ पे लाइट रे अगेन इट विल बेंड टुवर्ड्स नॉर्मल. I hope you understand. It will take a curved path like that. So, a light ray that enters over here will not exit here, it will be exiting somewhere here. The point is, because nothing has been said about N2 and N1, it may be that gradient of refractive index is very high. Let us assume that N2 minus N1 is a big number. यहाँ से थोड़ा सा भी ऊपर जाते हैं, refractive index changes a lot. In such case, the deflection will be sharp. लाइट रे का जो डिफ्लेक्शन है वो सब्सटेंशियल है. एक रे जो यहां पे एंटर हुई, जब बाहर निकली तो ऐसे डिफ्लेक्ट हो गई. ये एंगल सब्सटेंशियल है अगर N2 माइनस N1 बड़ा है. बट स्टिल इफ इट इज गिवन दैट D इज स्मॉल, स्टिल वी कैन एज्यूम कि ये लाइट रे का कोई लैटरल मूवमेंट नहीं हुआ, यहां से यहां निकली, बट दिस इज इग्नोरेबल, वेरी स्मॉल. वाई? इवन इफ दिस थीटा इज लार्ज, इफ D इज स्मॉल, then this deviation will be small. आप ऐसे ही सोच लो ना, थीटा यूनिफॉर्म ही मान लो, ऐसा मान लो, एवरेज डेविएशन थीटा. तो ठीक है भाई, अगर ये नंबर बहुत छोटा है तो ये हाइट तो बहुत छोटी होगी. अगर ये डी बहुत छोटा है तो ये बहुत छोटा है. डी टेंडिंग टू 0 कर दें तो ये जो चीज़ें टेंडिंग टू 0 हो जाएगी. तो इफ दी, what I am trying to imply is, if the gradient of refractive index is high, even if crossing through a thin glass slab, there could be good amount of deflection. Even if there is good amount of deflection, we can ignore this lateral movement if d is small. Even if theta is 30 degree, let us say. But if this d is very small, what is this lateral movement? Nothing. So if d is small, I am ready to accept that light ray inside the glass slab is almost straight. One simplification. But for that assumption, d has to be small. That is one thing. So let us assume that d is small. It is not given in the question, but we will assume that. So if d is small, then we are assuming that light ray is traveling like this, okay? But the deflection is not small. Angular deflection is not small. Now, assume that a wavefront reaches, after the light hits this surface, let us say a wavefront reaches this surface here after time delta t. We are assuming that light is traveling in a straight line. With that assumption, in delta t time, light reaches from here to here. It will definitely take less than delta t time to reach from here to here. And if you wish to draw a wavefront at time delta t, then this light will be traveling in air for some amount of time. Now, how do we draw wavefronts? If you have done the derivation of law of reflection and law of refraction based on Huygens theory, then you must be knowing it. Assume that time when light reaches here. उस समय पे हम वेवफ्रंट ड्रॉ करेंगे. तो ये अभी अभी एक पॉइंट सोर्स बना है. उसमें से जो स्फेरिकल वेवफ्रंट्स निकलेंगे, दे हैव जस्ट स्टार्टेड बलूनिंग आउट, रेडियस 0 है स्फीयर का. और ये वेवफ्रंट, ये सोर्स काफी पहले एक्टिव हो चुका है इसके लिए, क्योंकि लाइट यहां से यहां पहुंची डेल्टा टी में, हो सकता है यहां से यहां पहुंच गई डेल्टा टी बाई 2 सेकेंड में, 1/3 में. फॉर रिमेनिंग टाइम, this is a point source which is throwing wavefronts in spherical forms. इसको सेंटर मान के आप एक स्फीयर बनाते हैं. ऐसे ही बाकी के लिए भी आप कर सकते हैं, बस अभी हम सिर्फ 2 ही पॉइंट, रिप्रेजेंटेटिव पॉइंट्स ले रहे हैं. एक ये पॉइंट और एक ये पॉइंट. ये 0 रेडियस का स्फीयर है और ये सर्टेन रेडियस RL लिख लेता हूँ, L का स्फीयर है. तो ये जितने भी स्फीयर यहाँ बनेंगे, सबका टेंजेंट ये वेवफ्रंट है. दिस इज द वेवफ्रंट. दिस इज द outgoing emergent wavefront. So the mistake that is obvious here in this kind of diagram is you think that these are the rays and this is the wavefront. How can it be possible? If this is a wavefront, then how can this be a ray? A gross error. That is not possible. So ray is always perpendicular to wavefront. If this is wavefront, this is the ray. So this wavefront originally was like this. Now it has deviated by this angle theta. Now what is that? Theta. If this length is L, this is given as H. Sin theta is L by H. Not tan theta, it is sin theta. And again, either you can work in terms of time or again optical path length. That is perfectly same, nothing different. This optical path length, N2 into D, is same as this optical path length. This path length is N1D and this is L. So L is nothing but N2 minus N1D. N2 minus N1D by H. This is sin theta. So theta sine inverse of this in place of tan inverse of this, if it were sine inverse of this, it would have been more meaningful. But okay, you can argue that if you are taking D to be small, then this quantity is a small quantity, and therefore we can take sin theta as tan theta. let us agree to write this as tan theta, which is n2 minus n1d by h. No, I do not agree to this exactly. I think this is more appropriate. Even if d is small, nothing has been said about n2 minus n1. If n2 minus n1 is large, then what? D is small, but n2 minus n1, theoretically n2 minus n1 could be any value, very large number. So, okay, in practice, for kind of glass that we use in daily life, it may not be so large, but it is a theoretical question right now. We are discussing. So, if n2 minus n1 is large, even if d is small, this could be a substantial number. And it may be wrong to write sin theta as tan theta. So, what I am trying to imply is, if it is given that d is small, then okay, what we have done appears to be approximately correct. But still, I am not ready to write sin theta as tan theta. If it is given that n2 minus n1 is also small, or if it were given that the difference n2 minus n1 is less than 1, anything like that, then I would have agreed that, okay, let us write sin theta as tan theta. But the point is, why should we be doing that? Why not write sin theta? So that's all I wanted to highlight. I'm not saying that question is wrong or right. That is for you to imagine and decide. But what I came across was basically this kind of solutions, which are something that can give you a wrong concept. So that's why I took this question. Thank you. Goodbye.